Hi everyone! We're going to move on to our last topic for radicals, and that is solving radical equations. So our strategy here is going to be very similar to that for solving any type of equation, and a big part of that is going to be using inverse operations. In particular, if x only shows up in your equation one time, the entire solve process will just be using inverse operations to cancel out everything that's over there with the x. So remember, that's really an order of operations question first. So if we imagine plugging a number in for x, say I plugged in a 4, the first thing I would do is subtract 3. The square root is basically like parentheses. So that's a very first step, is to do the things under the square root first. The square root itself is the second step. The multiply by 4 is the third step, and the add 2 is the fourth step. So you need to take the last step and get rid of it first. Subtract 2 from both sides, and we will get 4 times the square root of x minus 3 equals 8. The next thing that we need to get rid of is the 4. It's attached by multiplication, so we will divide it out. The next thing that we need to get rid of is the square root. So this is a little bit of a new step, but I don't think it's going to be a big leap for our imaginations. The way we eliminate a square root is by squaring both sides. So I want to imagine squaring and squaring. 2 squared is 4. And then the last step will be to get rid of the 3 by adding 3 to both sides, and I get x equals 7. Okay, so this was the process. There's 2 important things that I want to point out. One is that you always need to isolate the square root before you square both sides. And that is basically to make sure that your inverses really do cancel. So just as an example, if you did the square root of x minus 1 equals 2, and you square both sides, squares don't distribute, so I can't just square the x and square the 1. So what I would really have to do is take the square root of x minus 1 times the square root of x minus 1, and the first step of that looks good. I do get rid of the square root when I multiply 2 square root x's together, but then I'm going to have a minus the square root of x, and another minus the square root of x, and a plus 1. And notice, well, I can combine these into negative 2 root x. I didn't eliminate the root. It's still there. So the reason it's not canceling is because order of operations here is you would take the square root, that's step 1, then you would subtract 1, that's step 2, then you would square. Because that minus 1 happens between the square rooting and the squaring, they don't cancel. So that's the first big thing. Always isolate that root so that the square and the square root happen immediately, one right after the other. Big deal number 2 is that when you square both sides of an equation, you can actually introduce an extra solution. This is not because you've made a mistake. It's just the way it works. So you always have to check for extraneous solutions. And extraneous, I'm just going to define that as extra invalid solutions. So the deal here is, for example, if you say negative 2 equals 2, that's a false statement. That's not true. But if you square both sides, it all of a sudden becomes true. So when you square both sides, you can make a statement that was initially false become true, which means solutions to the new equation you get after you square might be a little bit different than solutions to the old equations. You might get more. So it's not that you won't get the correct solutions. It's that you might get all the correct solutions and then some that actually aren't correct. So you have to check your solutions here. It's never a bad idea to check your solutions, but here it's not optional. And what's really important is that you go all the way back up to the original equation. And we plug in 7. We say 4 times the square root of 7 minus 3, which is 4, plus 2. And we want to know, does that in fact equal 10? So I get 4 times 2 plus 2, and that's 8 plus 2. It does in fact equal 10, so I will keep this solution. But you have to do that check. You can do everything perfectly, and you can still get an answer that didn't actually work. Okay, let's just do one more of these that aren't too messy, and then we'll work on some that end up being quadratic that are a little bit messier. So down below, we have the square root of 6y equals -4. So there, the order is first I'd multiply by 6, and then I'd take the square root, which means the first thing I need to do is square both sides. And I get 6y equals positive 16. So number one, there's some exponent stuff there that I bugged you about earlier in the quarter. When you square -4, it's not squaring the 4 and then multiplying by -1. We really squared the entire thing. You have to square the entire left side and the entire right side. You can't break it into bits and pieces. So it will be positive 16. And then when I divide, I get y equals 16 over 6. So not very hard to solve. Let's go ahead and do our check. When we do our check, we get the square root of 6 times 16 over 6. And we want to know, does that equal -4? And I can cancel the 6's, and I get root 16 equals -4. And you might be tempted by that because sometimes people get a little bit jumbled in their head. When we solve quadratics with square roots, we said you always need a plus or minus, but that was not actually a square root problem. That was a square problem. There's always two numbers that you can square to get a certain answer. With the square roots, they're really transparent about whether they're positive or negative. This is a positive root. If it was a negative root, it would have a minus out in front. And a positive root cannot possibly give you a negative number. So this is not possible. And we would throw this solution away. And since it was our only solution, we would say no solution. Or in my open math, it's probably a D and E, and that's fine. But technically, it's a no solution. So always check for those answers. And I would actually point out that if you're paying attention, in this case, you can probably see it all the way back at the beginning. I'm taking the square root of something and I'm getting a negative number. That's not possible unless it's a negative root, and it's not a negative root. So a square root is always going to give you something non-negative, I want to say. So it'll either be 0 or positive. You can get 0, but you can't get negative numbers. All right, so think carefully about the extraneous solutions. Thanks for watching.